So if you look at the formula, it's really a sum over a sum. And let's take a look at the denominator first because that's a lot easier. So it's the sum of yi minus y bar squared. So what you're seeing here is that yi minus y bar, that's your deviation from the mean of each individual point, yi. And then we sum them all, and then we square them. So this is the sum of the squared deviations. It's a pretty simple thing to calculate. We do that a ton in engineering, so that will be an easy one. The top is where it gets a little difficult and specific to the Shapiro-Wilk test. So this is the sum from I equals 1 to n over 2 of, and the sum is ai times y n minus I plus 1 minus yi. So y n minus I plus 1 is the ith ordered sample in descending order. So if you were to take all of your samples and you were to sort them in descending order, it's the I index of that array in descending order. Yi is the ith ordered sample ascending. So that's where that symmetric data points about the median comes in. So you're basically comparing the most extreme values, then the next most extreme, then the next most extreme. And then we're doing this, we're multiplying that deviation times AI, which is the ith constant from the Shapiro-Wilk table. Now, on the next slide, we will learn about the Shapiro-Wilk table, and we'll actually do an example of finding the constants. So another thing to note is that this sum is a little bit different. So the one on the bottom is just a sum sign. That's because we're going to loop through every single data point. But on the top, we go from I equals 1 to n over 2. And that's because you only want to compare each sample once. So that would be, you're comparing the most extreme, then the next most extreme, and etc. So each data point will be used once, unless you have an odd number of data points, in which case the median will be ignored, and that is expected from the Shapiro-Wilk test. So here we are in the Shapiro-Wilk table, and it's this giant thing, and it is very complicated. So when we get into Excel, I highly recommend downloading the workbook, link in the description, and that's a great chance for you to look at this table yourself. So if you want to pull that up, I think that's a great idea for what we're talking about, and you can work through it with me here. So the AI constant is found in this table, and the constants are arranged so that each column represents a sample size. So each of these columns is a different sample size of n. So we have from 2 all the way up to 50, because remember, it stops at 50. So then you'll notice that each row is an A1 constant, an A1, A2, A3, an AI constant. So let's do an example here to show how this works. Okay, so for example, let n equal 10. We have 10 samples. Our constants, so we're going to come over here and we find n equals 10, and our A1 constant is this value, our A2 is this, A3, 4, 5. So that's how you calculate, and they're all listed here. If you were to have, let's say, a sample size of 38, here would be all of your constants there. So pretty cool, pretty easy. In Excel, we will work out some functions, some worksheet functions that will handle all of that logic for us. So make sure to check that out. Link in the description if you want to skip there. But we don't have a whole lot left. Most of this is intense Excel programming. The concepts are pretty simple.